In this video, I am going to solve this system of linear equations using the substitution method. However, before solving the system, let me give you an outline of what it means to solve a system of linear equations. Let's assume that L1 is a line that's represented by one equation, and L2 is another line that's represented by the second equation. Now these two equations, when we solve them, what in essence we are finding is this point of intersection, meaning we are finding the coordinates of this point of intersection. This is going to be the x coordinate of the point of intersection. This is going to be the y coordinate of the point of intersection. So just to give you an overview, whenever we are solving a system of linear equations, we are finding the point of intersection for the lines in that system. Now, having said that, let's go and look at the actual system, and we notice that this system has two equations, and the first equation has x and y variables, and none of them have coefficient 1 or negative 1, and the same is true for the second equation. So it means that this system is not really suitable for the substitution method. However, I am going to use the substitution method to solve it, just to show that we can solve it using this method, or we can solve any system of linear equations in theory using the substitution method. The calculations here are going to be a bit more messy, but bear with me, we'll go through it. Let's look at the second equation, which is, by the way, 4x plus 5y minus 6 is equal to 0. And I'm going to solve for x in this equation. So I subtract 5y from both sides, add 6 to both sides. If I did that, I get 4x on the left, and positive 5y, negative 5y cancels, negative 6, positive 6 cancels, and that gives me negative 5y plus 6 on the right. Now I'm going to divide both sides by 4. If I do that, I get x is equal to negative 5y plus 6 over 4. And that's the x that I get from the first equation. Now I'm going to take this x and plug it into the first equation, which, by the way, is 9x. So it's going to be 9x minus 10y plus 1 is equal to 0, or 9 times x, negative 5y plus 6 over 4 minus 10y plus 1 is equal to 0. Now there is a 4 in the denominator here, so what I am going to do, I am going to get rid of this 4 by multiplying everything by 4. So multiply everything by 4, and 1 times 4, actually let's just make this a 4. If I multiply it by 4, 1 times 4 is going to be 4, and 0 times 4 is 0. So on the left hand side, this and this is going to cancel out. That's going to give me 9 times negative 5y plus 6, and then 10y times 4 is 40y, and there's a negative in front of it, plus 4, and on the right 0 times 4 is 0. Now use the distributive property to simplify it. Negative 45y plus 54, 6 times 9 is 54, minus 40y plus 4 is equal to 0. 45y negative minus 40y is negative 85y. 54 plus 4 is 58 is equal to 0. I subtract 58 from both sides. If I do that, I get negative 85y on the left positive 58, negative 58 cancel out. On the right hand side, negative 58. Now I divide both sides by negative 85. So negative 85y over negative 85 is equal to negative 58 over negative 85. This and this cancel out, and that's going to give me y is equal to 58 over 85, and that's my y. Now I take this y value and I'm going to plug it right in here to get the x value. So x is equal to negative 5y plus 6 over 4, or x is equal to 1/4 times negative 5 times y, but y is 58 over 85, then plus 6, and I'm going to simplify it further, 1/4. Now 5 goes into 85 17 times, so it's going to be negative 58 over 17 plus 6. Now I'm going to multiply 6 by 17 and divide 6 by 17 so that I have 17 in the denominator, and I will have x is equal to 1/4 times negative 58 over 17 plus 102 or 102 divided by 17, because 6 times 17 is 102. And if I continue, I get 1/4 times negative 58 plus 102 over 17, and I go further simplification times, this is gonna be 44, not 64, 44 over 17. Negative 58 plus 102 is 44. Now 4 goes into 44 11 times. That tells me x is equal to 11 over 17. So x comma y is equal to 11 over 17 comma 58 over 85. And that's what it means to find the solution for this system of linear equations. Now if I were to sketch it, this is how it's going to look like. Let's say one of the equations looks like this, another equation looks like this. This point of intersection is this point. And that's what it means. I hope that this discussion was helpful. Thank you very much.